Cell longevity is connected to something called telomere length in a very particular way. So what you have to bear in mind, first of all, is that an average person is about 37 trillion human cells. Many different types of cell, but there's about 37 trillion. When you were first made by your biological mum and dad, there was one, okay? It was the fertilized egg. And what happened is that one divided into two, then into four, then into eight. So this division process has happened throughout your whole life. All human life grows in that way, through this gradual breaking apart of cells into two daughter cells. Inside every one of those cells is DNA, and everybody has heard of DNA now. It's the instruction code. It tells you everything that's going on inside that cell, everything that's got to happen. And we all know that DNA is an intertwined helix. Now, when you create your two new cells, you break into two. What happens is the DNA is unraveled and two new pieces of DNA are added. So you end up with a piece of DNA to go into one of the new cells and another piece of DNA to go into the other cell. So this unwinding of the DNA and copying and placing into the two new cells has to go on. And obviously that has to happen a lot throughout your life because you've come up to the size of 37 trillion cells. Now, every time you undo the DNA to do the copying, it's a little bit like a zip on a cardigan, okay, or on a jacket. You unzip it and you open up the two bits of DNA and you can copy along those. Now you know at the bottom of a zip there's a little piece of metal that the zipper hits and it stops the zipper from coming off the zip, right? You have them on your DNA as well. You have to have them because otherwise the machinery that copies the DNA is going to end up falling off the end and it won't work, right? That little bit at the end is called a telomere. And so that is a buffer, and every single time you divide your DNA and you break into new cells, it gets a little bit shorter because the copying machinery will run into it. So when you start life at birth, you've got what's called about 11,000 base pairs, right? So that's a measure of length of it. And when you're in very old age, that's got down to about 4,000 base pairs. So throughout your whole life, it's getting shorter and shorter with each division. The rate of decline is actually a little bit faster for men than it is for women. And then what happens is, once a cell has got to the point where the telomeres in a cell now which is dividing into two more, that telomere has got too short, the cell decides, I better not divide anymore because this isn't going to go well. So the cell basically stops dividing, okay? So it goes into what we call senescence. Or it decides that it needs to deconstruct itself, which is this programmed cell death. But what that means is that the organ that the cell's in, whether it's your skin or any other organ, cardiovascular, has fewer and fewer active cells within it. And this is really what's going on in aging. So in other words, the longer your telomeres, the younger you are. The shorter the telomeres, the older you are. And we also find that in disease conditions, things like cardiovascular conditions, for example, you do see telomere length is shorter in that disease state than it is in the healthy state. So having nice long telomeres is actually very beneficial for health span.